Problem number 4, we're given that there's a point P on the graph of y equals 1 over x. So we draw the graph of y equals 1 over x. We put a point P on there, but let's do it strategically. We're going to come up with a function that expresses the distance from point P to the origin. So let's just put the point P out here that has the coordinates x comma y. But also, as long as we are here, we might as well express the coordinates as x comma, instead of y, we'll write 1 over x. So we can take care of that expressing y as a function of x to begin with. So any point on this curve would have an x coordinate of x and a y coordinate of 1 over x. And then we have to draw a line segment from that point to the origin, and the origin obviously has the coordinates 0, 0. And so part A, it says express the distance d. So d equals the square root of from point P to the origin as a function of x. Well, we take the difference in the x coordinates, x minus 0 squared, plus the difference in the y coordinates, 1 over x minus 0 squared. There's the distance, but let's simplify that a little bit. X squared plus 1 over x squared, which is 1 over x squared there. And then if we get a common denominator, we get x to the 4th over x squared, all under the radical, plus 1 over x squared. And then we get x to the 4th plus 1 over x squared, all still under the radical. And I suppose we could bring this out of the radical, x to the 4th plus 1 all over x. The square root of x squared is x. Now, since this is a distance, it has to be positive, and so we better put the absolute value of x there to make sure it's positive. And then, so that's the distance. So distance equals the square root of x to the 4th plus 1 all over the absolute value of x. All right, so that's part A.